Hey everybody, and welcome to the section 6.6 video about trapezoids and kites, the two favorite kinds of quadrilaterals, and it's because they're the most fun. They have fun shapes, they're not boring, they have some personality. Okay, so let's get into it, and let's talk about trapezoids first. Everybody knows that a trapezoid has two bases that are parallel. I have labeled them here and here, and it has two pairs of base angles. Base angles right here, there's a pair of them there, and there's also a pair of them up here. So this and this are base angles, one pair, and here is a second pair of base angles. And then the other thing you need to know about trapezoids is that the non-parallel sides are called legs. So we've got two legs here. They can be congruent. They don't have to be congruent, but they're certainly not parallel. Okay? Parallel sides are called bases. Non-parallel sides are called legs. And trapezoid also has two pairs of base angles, as we just discussed. Now that we know that, let's see if we can do something with it. Oh, first, isosceles trapezoid is just like you might expect with an isosceles triangle. In fact, you can draw an isosceles triangle out of it with that side and that side being the same. Okay? But an isosceles trapezoid is simply one where both legs are congruent. Okay? And your most standard kind of trapezoid, when you think of a trapezoid, you probably think about one just like this, an isosceles trapezoid. Okay, now let's do some math. We've got theorem 8.14. If a trapezoid is isosceles, then each pair of base angles are congruent. Those of you who are real familiar with your theorems from triangles probably recognize this, because in a triangle, if you had an isosceles triangle, then you knew that both pairs of base angles were congruent. Same thing with trapezoids. If you have an isosceles trapezoid, which is clearly missing from your diagram this and this, if those are the same, then you know that each pair of base angles are congruent. So notice this and this are congruent, but also these down here are going to be congruent. Okay? And I haven't even covered up the example here. So if you have an isosceles triangle, then angle A is congruent to angle B, and angle C is congruent to angle D. Okay? Pretty straightforward. Also, we have theorem 8.15, which says that if a trapezoid has a pair of congruent base angles, then it is isosceles. Okay? And I have drawn two pictures for you to think about, because either of these gives you enough information to say that the trapezoid is isosceles. If you know that angle A and angle B are congruent, or if you know that angle T and angle H are congruent in this second figure, then you know that you have an isosceles triangle. So you can easily say that those are all congruent. Okay? So in trapezoid ABCD, angle A is congruent to angle B, so it is an isosceles trapezoid. And in trapezoid MATH, angle T is congruent to angle H, so you know that you have an isosceles trapezoid. Any questions? Good, let's go on. This one is for you guys to do. It tells you have an isosceles trapezoid, and you simply have to find x. Couldn't make it any easier for you guys. This one, just about as easy. We go on to theorem 8.16. A trapezoid is isosceles if and only if its diagonals are congruent. So this one's kind of fun and pretty simple to understand as well. It's saying that if the only way that you can have an isosceles triangle is if, well, first of all, you have your two legs that are congruent, but the only way that you can have that is if this green line here, which I'm covering up with red right now, and if this purple line right here, which I'm going to cover up with black, if those are congruent to each other. Okay? It works both ways. If the diagonals are congruent to each other, then you must have an isosceles triangle, or a trapezoid. If you have an isosceles trapezoid, then those diagonals must be congruent. Okay? So in trapezoid ABCD, we know that AC is congruent to BD. Therefore, we have an isosceles trapezoid. And it occurs to me that nothing on the diagram actually told us that these were the same. So I'll go ahead and do that right now. Let's say that that's X. So we know that this must be X. Okay? Let's see what we can do with that. Okay, we've got this example here. PQRS is a trapezoid. Find the measure of angle S and the measure of angle R. All right, so because we know that this is a trapezoid, well, because we know it's a quadrilateral, really, we know that we have to add up to 180 degrees, or 360 degrees, rather. Let me just see if it's on the next slide here. Yes, we actually have two options for this. Okay, option A, is that the sum of the interior angles of a quadrilateral is 360 degrees, and that comes from our formula for the interior angles sum that we did in section 6.1. So we get that adding all four of these up, 6W plus 2 plus 3W plus 147 plus 112 gives me 360. You can combine like terms, and then you have a two-step equation. You solve for W, you get that W is 11, and let's see if that answers the question. No, find measure of angle S and R. So then we are going to, I'm just going to hide this off to the side. We just plug in W for what S and R are, and we get that measure of angle S is 68, and measure of angle R is 33. I want to go back to the picture real quick. And I want to caution you, when you see a question like this, don't assume, hey, that looks like an isosceles trapezoid, so I know that this and this must be the same. First of all, you know it's not isosceles because these two base angles are not congruent. But also, remember, I've told you time and time again, you cannot assume that a picture is drawn to scale. So there's no way that you can assume this is isosceles because these two marks here were never made, so you don't know that they're congruent, so you have to use other methods. Now, there is another option that we had, option B, for answering that same question. We know that parallel lines in a trapezoid create pairs of consecutive interior angles. Let me bring this picture here so that we can actually see what that's saying. I'm going to erase this real quick. Okay, and then I'm going to take this picture and I'm going to copy it, and then we're going to go to the option B here, and I'm going to paste it. Okay, I'll make that a little bit smaller. Oops. Not happening exactly like I want it to. I'm trying here, folks. Doesn't help that my computer's a little bit slow. So as this is deciding to shrink or not, we can chat about movies or something. Seen any good ones lately? I particularly am looking forward to seeing the movie of the trailer I just saw, which is Two Guns. That looks really good, and I like Denzel Washington, and Mark Wahlberg never hurts anything, so that's good too. Okay, let's go on to math. We know that the parallel lines in trapezoid create pairs of consecutive interior angles. Okay, so we've got parallel lines. That's an unfortunate color to choose. We have two parallel lines, and we have transversals. Okay. Cancel. We've got a transversal. So I know this right here and this right here, just from looking at the picture, you can tell those are consecutive interior angles. So you know they must add up to 180. So measure of angle Q plus measure of angle R must give you 180. And the same thing goes over here, because we can also draw another transversal. We can draw this I apologize. Waiting, waiting, waiting. Of course my computer's not responding. Okay, so we can also draw this transversal right here, and we know that this angle and this angle here are consecutive interior angles, so they are also supplementary. So we can say measure of angle P and measure of angle S add up to 180. And from there, it's not real hard to plug in your angles and solve for S and for R. And once again, we get the same thing for S and R. Okay, let's move on. Let's try this one. PQRS is an isosceles triangle. Find the measure of angle Q, measure of angle R, and measure of angle S. Now, the key word here is isosceles, not trapezoid. Just by looking at the shape, we can tell it's a trapezoid, but they're telling us it's isosceles. We know those are parallel. We also know that this angle and this angle are congruent, and this angle and this angle are congruent. So it's pretty straightforward to find all of these then, because angle P must be congruent to angle Q. So we know that 123 is equal to 9W minus 3. We will add 3 to both sides. We get 126 is equal to 9W. We divide by 9. We divide by 9. I cheat and use a calculator. And I get that W is equal to 14. Okay, so I have found W. I'm going to hold off on finding my actual angles until the end because, or I'm sorry, no, I didn't even realize this one is W, so I don't even need to do anything with measure of angle S because they've already told me that the only variable I needed to find was W. So for measure of angle Q, I am going to say that I have 9W minus 3, which is equal to 9 times 14. I'm going to pause the video real quick and align my board because it's getting worse and worse. And we're back. So we get that measure of angle Q is equal to 9W minus 3, which equals 9 times 14 minus 3, which is equal to 126 minus 3, which is equal to 123 degrees. Okay? That's awfully familiar. Huh. What do you know? It is isosceles. So that was incredibly useless of an exercise because you know that this and this had to equal each other. So we already had the measure of angle Q. What we don't have is the measure of angle R or the measure of angle S. Okay? So what we're going to do is we are going to say that the measure of angle S is equal to 4W plus 1, which equals 4 times 14 plus 1, which equals 56 plus 1, which is going to equal 57. And the thing is, I don't need to find the measure of angle R because this is isosceles. I know that this one here, 57, must be the same as this one here. Measure of angle R is also 57, and we are done. Okay, I'm going to leave this one for you, this one for you, and we're going to talk about the mid-segment of a trapezoid real quick. The mid-segment of a trapezoid is the segment that joins the midpoints of the legs. Okay, so very simple. We take the two legs, we chop them in half, okay, and we put a point right there. We take this leg, we chop it in half, we put a point right there, and then we just join those 2 points. Okay, so you know that this and this will be the same, and these will also be congruent. Okay, so pretty straightforward. The thing we also know, which we're going to talk about in a theorem, is exactly what it looks like. These two lines here are parallel, and so this looks parallel too, doesn't it? Let's do that a little bit more formally. Okay? The mid-segment theorem for trapezoids. The mid-segment is parallel to both of the bases, and the length of the mid-segment is half the sum of the bases. Okay? So, the first part's very straightforward. They're all parallel. Okay? So you can say that AB is parallel to EF is parallel to DC. The other part is not all that much more complicated. What it is saying is that EF, it is saying that EF, and I don't want you to mistake this to think that I'm saying segment EF. This is the length of the segment EF, is going to be equal to adding up AB and DC and dividing by 2. So it's 1/2 of AB plus DC. So we add up this length here, we add up this length here, we divide by 2, and that is the length of that one right there. So it's basically the average of the two lengths. Okay? Example, PQRS is a trapezoid. Find the mid-segment LM, and what they're asking for, notice there's no bar over here, so they're asking for the length LM. LM is simply equal to QR plus PS divided by 2, which is equal to 15 plus 7 divided by 2, which is going to equal 22 divided by 2. What do you know? That's 11. See how simple that is? It's like we're going back to 6th grade. Okay, now we've got a slightly harder one, but I don't really think it's that much harder. It's asking us to find PS now, which is not the mid-segment. It is one of the bases. However, the same formula is true. The mid-segment, LM, is equal to half of the lengths of the two other segments added up. So QR plus PS divided by 2. Now we're just going to plug in, and we're going to have to solve our formula a little bit differently, but the same thing applies. LM we know, that's 14.5. QR we know, that's 20, but PS is kind of by itself over here. Okay, and this gives us a great opportunity to practice some algebra. We are going to multiply both sides by 2 as one option. Okay, and those 2's will cancel out because 2 divided by 2 is 1. And we've got 2 times 14.5, which is 29, is equal to 20 plus PS. Now I could subtract 20 from both sides, or I could just look at my formula and see, hey, 29 equals 20 plus what? PS must equal 9. Okay? We're waiting. We're waiting. We're waiting. Go. Okay, let's try this one. We have PQRS is an isosceles triangle. We want to find X, Y, and Z. Okay, so let's move this over a little bit because it's kind of in the way there. And this is pretty straightforward. First of all, we know that it's an isosceles triangle, and so we know that, I'm sorry, there is one other thing that we need to be told before we can answer this. Okay? Does anybody know what it is? Okay? We need to be told that ML is actually our mid-segment. It is not. That should be in there. ML is mid-segment. Because otherwise, there's a lot of this that we can't actually do. Okay? But I'll tell you, ML is the mid-segment. And so I know that Y and 5 must be the same. 7 and Z must be the same. So, very quickly, I can say Y equals 5. 7, or Z equals 7. And notice, this length right here is 10. This length right here is 14. They are not the same, and that doesn't really matter because The only way they would be exactly the same is if you have an isosceles trapezoid, which I do. This is fascinating. What did I do wrong? Don't you just love it when Mr. Duncan screws up? Okay, so we've got an isosceles trapezoid. Let's start again and assume that the question maybe was right. If I was more vain, I would edit this section out, but, you know, teachers make mistakes too. So let's see what we can actually figure out. We know that this is an isosceles trapezoid. This is a good lesson too about why you read questions carefully. Okay? So that side and that side we know must be the same. Okay? So 7 plus z plus 7 is equal to y plus 5. And once again, there's not enough information here. Okay, let's scrap this question because there's not enough information to be able to solve this one. I apologize for wasting your time. Okay, but these I will let you do on your own. And I think we can go right into, oh, I just wanted to highlight, I added this in. Be careful with this one because this answer is not quite as easy as you think. And then we will go into kites. Okay, let's try to do this pretty quickly. A kite is a special kind of quadrilateral with two pairs of adjacent congruent sides, and opposite sides are not congruent. Okay? So it is saying that we have adjacent sides that are congruent, and that this side here cannot be equal to that side over there, and vice versa. Okay? So that's what's special about a kite. Okay? There are several interesting theorems that come up from that. Theorem 8.18, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Notice the word exactly here. Okay? If we have a kite, then the angles in between different sides, this one is marked with a 1, this one is marked with a 1, this one's marked with a 2. So the angle in between there is going to be congruent to the angle opposite it. And you know also that angle A is not going to be the same as angle C. That's very important as well. So in kite ABCD, you have angle B is congruent to angle D, and angle A is not congruent to angle C. Okay? Let's see what else we've got. Well, let's do an example first. LMNP is a kite. Find X. Well, this is a pretty good question. I like this one. Where we first have to realize that this is a quadrilateral, so we can find that the sum of all of the angles together must be 360 degrees because we have 4 sides. And also, you know that one pair of opposite angles in a kite are congruent. And we can clearly see that L and N are not congruent, so M and P must be. Okay? So let's go on to the next slide where this is actually worked out. Okay? And we have that, exactly what I just said. The 4 angles together add up to 360. We have that 72 plus 48 plus 2 of these guys here, x squared minus 1, is going to equal 360. So when we add up our like terms and combine our like terms and try to solve, we get that 2x squared equals 242. So we divide both sides by 2. We get that x squared equals 121. Now everybody knows that 11 times 11 is 121, but do not make the mistake of forgetting your negative 11, because there's nothing saying x can't be negative 11 here as well, because negative 11 will give you the exact same thing, namely that you have 120 degrees here and 120 degrees here. Okay, so there are 2 answers to this question. Let me just make sure that we did answer the question correctly. It was saying find x, so we have found x. X is positive or negative 11. Okay, number 8 is for you, number 9 is for you, number 10 is for you, number 11 is for you, and we are on to theorem 8.18. If a quadrilateral is a kite, then the diagonals are perpendicular. This one's fun, and it's pretty easy to remember too, because, hey, look at that picture. Doesn't that exactly look like what you used to fly as a kid if you flew kites like I did? These are your cross beams that support the kite itself when you're flying it, and so they will always be perpendicular. Okay? There's nothing hard about this. In kite ABCD, AC is perpendicular to BD. Okay? And so I will leave these for you. I think there are two of them. No, I erased the second one. And we are done with our video. And thanks for watching, folks.